All right, welcome grade 9 to chapter 4, scale factors and similarities. We're going to be working with kind of relationships between different objects in this chapter. We're starting off in 4.1 with enlargements and reductions, and we'll kind of be working with that moving forward in the chapter. So in this section, we need to know what an enlargement is, which is pretty much exactly what it says. It's when you increase the dimensions of a shape. So here's something that's an enlargement of something smaller. And then we'll get into scale factor. It's the constant factor by which all the dimensions of an object are enlarged or reduced. And so we'll talk about how we can use scale factor in a couple of the examples here in this section. So identifying enlargements, interpreting the scale factor, and actually drawing them, actually making the shape either bigger or smaller, depending on the scale factor. So we have a couple of examples here. From your book here, this is example 1. It says draw the picture with dimensions that are twice as large as the original. Okay, so for us, if you're going to draw something that's twice as large, we need some sort of reference point. Otherwise, you've got to grab your ruler and actually measure how big this is. So for us, using grid paper is going to be kind of a reference point to help you draw something that's twice as big. So twice as large means that all the dimensions need to be increased. So if I just draw this, and we'll just use one of these, but let's say we draw kind of an arrow that looks like this. Okay, it's a little bit maybe smaller than the one we have there, but that's okay. If we have now a reference point on the grid paper, we can work with that. So if it's going to be twice as big, that means everything on the shape is going to be twice as big. So if I look at the main part of it, this was 4. So if I'm going to make it twice as big, it's going to be 4, 8. Okay. Then if I kind of zoom in on the arrow part of it, this is going diagonally across one box. So now what it's going to be doing if it's twice as big is it's going to be going diagonally across 2 boxes. And so it's going to look like this. And same with on this side. Okay, same thing over here. It's going diagonally across 1. So this is all just doubled. And we end up with an arrow that looks like this. Boom. We've got a picture that's twice as large. All the dimensions, every part of it has to increase by the exact same amount. Otherwise, it's not a true enlargement. Okay? So that's example 1. We can do this with any type of shape that we're given. Typically, you're going to be given certain 2D shapes in this section. So with this one, it's a little trickier to do. It's not just a straight line. So what I like to kind of practice is just to think of this as how much space does this whole thing take up, and kind of just take it as a rectangle. So this rectangle that's around this shape is 4 by 5. Now it says use 2 methods. We're just going to do one. We're just going to figure out how to do this. We want to draw it with dimensions that are 3 times as large. So if it's 3 times as large, that means the width and the length are each going to be 3 times as big. So I'm just going to take this as this point, and instead of having 4 across, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, which is 12 times, which is 3 times as big. Same with this one. We've got 5. So we're going to go down 1, 2, 3, 4, 5, 10, 11, 12, 13, 14, 15. So hopefully I counted that correctly. And you're going to come up to here. Now this is kind of the size of the box where this shape needs to fit inside. Okay, so if you start with that, now you can pick a point and start at that point and then just kind of work your way around the shape. Okay, so here, this point here is right in the middle of the box. So we're just going to go and start right in the middle of the box. You don't have to start at this point. I just think it's easiest. Okay, and then so we can do the same thing over here. This is halfway in between. So we got 2, 6, 7.5, right? It's going to be halfway, so this is going to be 7.5, and this is again going to be 6. Okay, now if I just kind of work our way down, if we want to make this 3 times as big, if I take a point here, if I want to get to that part of the shape, here we had to go down 2 squares, so here we're going to have to go 1 or 2, 4, 6 to get to that same point, right? And we're going to have to do a little bit of estimating here. Here it's about halfway from that point, half of a square. So we're going to have to triple that. So instead of going half of a square, we're going to have to go 1.5 over. Okay, and same thing on this side, we're gonna have to go 1.5 over. Okay, and so that should kind of get us started here on our shape. Once we kind of get it going, we'll be able to fill the rest in. So from here, then we should be able just to fill this in, right? Because it's going from here to here. So if I have this point already, I know that it's going to go there. Okay, here to get to this point, we've got to jump up 2, just like on the other side. So we're going to have to jump 2, 4, 6. We're always going to triple it. So if the one dimension changes, we've always got to triple it. So this is about half of a square. So again, we're moving over 1.5 squares this way and 1.5 squares that way. Okay, and voila, we have our shape. That's going to be 3 times as big. Dimensions are 3 times as big. Okay.